Hello class, welcome back to another video. Today we'll be talking about first the parts of an atom, and then we'll get into determining how many neutrons, protons, and electrons are in each element. But let's start with the parts of an atom. We have a cool little video of a element. This is for our carbon element, and inside this we have an atom, or this is an example of an atom. So the atom has four important pieces. We have the nucleus, which is this center. At the center, it contains the protons and neutrons. Well, what is a proton and neutron, you may be wondering? Well, a proton is a positively charged particle, and again, it's in the middle of the atom. It is also equal in number to the electrons, unless it is an ion. So for every proton, there is an electron. Then we have our neutrons, which again are in the middle of our element. We have, each neutron is a neutrally charged particle, and they're equal in mass to a proton. So they are measured in atomic mass units, or AMUs. So every amount of mass that a proton has, a neutron equally has. And then we have, last but not least, our electrons. So our electrons are negatively charged particles found on the outside of the atom. So these 6 little balls orbiting the nucleus are our electrons, and also these are incredibly important when it comes to chemical bonding. So going back to our proton, it says it's equal in number to the electrons because for every positively charged proton, you need that many negatively charged electrons to have a neutral atom overall. Awesome. So we're going to start talking about identifying the amount of protons, neutrons, and electrons. But our question here says, how does the amount really of each of these 3 change within an element? So we will start with protons. Protons are equal to our atomic number. If we go back to our carbon example, our atomic number is 6. We have 6 protons, and so they're equal to our atomic number. It is also, as the atomic number increases with the element, the number of protons also increase. Then we have our neutrons, which again are equal in mass to our protons. And as the elements get bigger, as the atomic number increases, the elements get bigger, the number of neutrons increase. It gets heavier. Then we have our electrons, which are equal to the number of protons and the atomic number, unless it's an ion. So we will talk about ions a little bit later, but again, we have to have neutrally charged, or for now we have neutrally charged atoms. So for every proton we have, every positively charged proton, we have a negatively charged electron. So let's go through some examples. I think that's the best way to learn this information, is to show a lot of different examples. So let's first start by teaching you how to read what this says. So we have iodine is our element. We have our abbreviation is just a simple I. This 53 is our atomic number, and this 126.90447 is our atomic mass. These extra numbers show how many electrons there are, but it's a little bit confusing and they aren't necessary for what we're doing. So right now we just need the atomic number, 53, and the atomic mass, 126.9, and some change. So again, I listed that out here. So how many protons would we have? Looking back at our definition, our number of protons is equal to our atomic number, so we should have 53. How many neutrons would we have? Now, the way to determine the amount of neutrons is to take the atomic mass and subtract the amount of protons. So we're trying to find the difference between the two. That is because the majority of the mass comes from the neutrons and protons, so those two make up that big number. I rounded up here to 127 because 9 is bigger than 5, so we round up to 127. Asking that great question, are you 5 or bigger? If you are, we round up. If you are not, we round down. And we can see my little difference here, and our answer is 74 neutrons in this element. Oh, and then again, we have the same number of protons as we do electrons, so we should have 53 electrons. We have another great example of hassium. That's also a fun word to say, so please, I encourage you to pause the video and think about how you would answer the number of protons, neutrons, and electrons before continuing. But as we're looking through this, we have, this should say hassium, not iodine, but hassium has an atomic weight of 269, and the atomic number is 108. So the number of protons should be equal to the atomic number and be 108. The number of neutrons should be the difference between 269 and 108. So we have our little math problem, and our difference is 161. And finally, our number of electrons should be equal to the number of protons and also to the atomic number, and it is at 108. Awesome. We got another example. Tennessine, I believe is how you pronounce it. Again, I forgot to change iodine's name. My apologies. But our atomic weight is 294, as we can see from up here. This looks a little bit different. We have our atomic number on the top and our weight down here. But for Tennessine, we have our atomic weight on the top right at 294 and our atomic number at 117. What if you can't tell the difference between the two? Well, our atomic weight is always going to be the bigger number because the atomic number also tells us the amount of protons involved. So we have to have have a larger weight than we do protons because we have a lot of neutrons as well. So it's always the larger of the two numbers. So number of protons for this example is 117 because that is our atomic number. Our number of neutrons is the difference between 294 and 117. We have our math problem, which is a great little math problem, and our answer is 177. Finally, the number of electrons, again, is equal to the number of protons, so we have 117. So those are some great examples. But what if we're giving the number of protons and neutrons and not the atomic weight or the atomic number? So, for example, an element that has 5 protons and 5 neutrons, what is the atomic number? Well, using our definition that the atomic number has the same number as of protons, our atomic number is 5. And then using the definition that our atomic weight is the number of protons plus the number of neutrons, we have an atomic weight of 10. And of course, our number of electrons are the same as our atomic number and our number of protons, so that is still 5. This is also a periodic table for your guys' use. Please refer to this. Another great example of a periodic table is ptable.com. This has each element on there. It has the number on the top and then the weight on the bottom, the abbreviation, and the full name for every element. So this can be very useful when doing homework or any other example. If there's ever a situation where I tell you not to use other other resources, a periodic table is definitely you are definitely able to use a periodic table always, and it's very important to use one. But please don't be using things like Google or any other searches to get the answer. I want you guys to be able to work through the problems your own, not give me an answer someone else has that you found. So that is our end of our lecture for today. I hope that was clear. If you have any questions, please let me know, and I look forward to hearing from you.